All right, so lesson today is over quadratic formula. I do not sing very often at all, and I'm not sure if you can actually call this singing, but the quadratic formula is one of those formulas that you need to memorize. And unfortunately, it's a little bit more complex than like Pythagorean's theorem. So Pythagorean's theorem, a squared plus b squared equals c squared. Remember, a and b are the legs of a right triangle. The c is the hypotenuse, and that's pretty straightforward. The quadratic formula we developed Monday, and you do need to have it memorized. I memorized it to the tune of Pop Goes the Weasel, so I will do the best I can at saying it for you, and maybe that will help you remember it as well. But it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So, yeah, I know that's not really singing, but I was trying to get it at least to the tune. Those of you who are better singers than I, then go for it. But again, let me say it one more time just to make sure, because this is something you need to have memorized. And it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, when we say negative b, that does not mean you're always going to make it negative. It's really the opposite of b. So make sure you recognize that. I also want to make sure that you keep in mind this is a negative sign within, a subtraction sign within the square root. And you are multiplying 2 times a in the denominator, and that is the denominator of the entire thing. So I'll do 2 practice problems. You'll get 4 of them on your assignment, and you can let me know today how it goes. The thing about the quadratic formula, again, you are solving for x. Remember, these are your zeros of the equation, and your equation must be in standard form. So none of your problems today are going to be written in standard form to begin with. So make sure that you get it in standard form, where it's a times x squared plus b times x plus c equals 0. So in this particular problem, I'm going to go ahead and add 16 to both sides, keeping the equation balanced. That gives me x squared minus 8x plus 16 is equal to 0. Now that I have that, the quadratic formula works beautifully, because I know that my a is equal to 1, and I would go ahead and write this just so that you have it to visually see what your a, b, and c are. B is equal to a negative 8, and c is equal to 16. So you simply plug this into the quadratic formula, which says that x is going to equal the opposite of b. That means a negative 8 is going to become a positive 8, plus and minus the square root. When you do b squared, it does not matter whether your b is a negative number, because negative times negative is positive, or whether your b is a positive number, because a positive times a positive is a positive number. So when you square this b right here, you are always going to end up with a positive number right there. Please do not ever make that negative, because b squared, negative times negative is positive, positive times positive is positive. So we've got the opposite of b plus or minus the square root of b squared minus 4 times a times c. All of that is over 2 times a. And that is the way I write the first step. After I've written my a, b, and c, I'm going to always write this b squared. You're going to be able to square whatever b is. So I write it in squared form. I also will always write the minus 4ac. I'll write that out so that visually it helps me solve this. So now I'm ready to simplify. I'm going to put 8 plus and minus the square root. At this point, I'm going to do 64 minus whatever 4 times 16 is, which is 4 carry 2. Is that? No, that's not. 16 times 4 is 64. How awesome is that? I should have totally remembered that when I worked that out. And this problem works wonderfully because you end up with x equal to 8 plus or minus 0. Square root of 0 is 0. Divided by 2, and 8 divided by 2 is 4. So if you remember when we did factoring, sometimes we found that there was only one 0 or one solution, which just means that the vertex of this particular parabola is right on the x-axis. No, yes, the x-axis. So does not happen frequently, but it is nice to see it here on this first one. Your square root simply drops out. Let me do a second problem for you and then let you have some to practice. And second problem is going to say 3n squared is equal to 5n minus 1. Now, I do know on your homework, there's another one that's like this. And if you simply want to move the n squared term over to the other side, it's totally fine. Like quadratic formula, you're just plugging it into the formula, so it doesn't matter whether it's positive or negative. There is one on your homework that it definitely is easier to just move the x squared term. Sometimes I will subtract the 5n and add the 1 so that my a is positive. Does not matter at all in this case. So I'm going to go ahead and just subtract the 3n squared because I do know that on one of them you are definitely going to have at least I'm pretty sure, you're going to have a negative lead coefficient. So we'll do one like that and just let you see that it works the same way. So we have negative 3n squared, we have plus 5n, and we have minus 1. So my a in this case is a negative 3, my b is 5, and my c is negative 1. So I'm ready to use my formula. X is equal to the opposite of whatever b is. In this case, the opposite of 5 is negative 5, plus minus the square root, b squared, 5 squared is going to be 25, minus 4 times a times c. And you can see writing this out is just visually, it's going to help you make fewer mistakes than trying to do it all mentally. And divide that by 2 times a. So we're ready to simplify. We have x equal negative 5 plus and minus the square root of 25. And I usually go ahead and put a minus sign right here. A minus sign being multiplied by a negative, these two negatives are going to cancel out and give you a positive. And that does happen on occasion. If one of your terms is negative, then when you subtract a negative number, it's going to end up being an addition sign right here. And you're going to be adding 12, 4 times 3 times 1. That is going to be divided by negative 6. So we end up with negative 5 plus or minus the square root of, looks like 37 over negative 6. Now, what you will do as far as on your homework assignment, you are not to leave it in this form. You're to plug it into a calculator. And when you plug in the, I hope we can, that's up high enough. When you plug in the negative 5 plus the square root of 37 and divide that by negative 6, you're going to end up with, if I can find it here, did I simplify this? Oh, I did, but it's not written on this page. It's on my other page. So you will get an answer for that. Great. Way to go, Mrs. Johnson. And then we've got a negative 5 minus the square root of 37. And then go ahead and take that and divide it by negative 6. I know it's written over here because this was one of, oh my goodness, how ridiculous is it? There it is. 0.23 and 1.43. I think this one ends up being, oh, I can't remember which is which, but one of them is 0.23 and the other one becomes 1.43. So I don't remember which was which, because I actually worked it 2 different ways and I can't remember which one goes where. So anyway, I will take a picture of your textbook assignment. It's going to be from my textbook again so that you can check your work. And again, this is all an integrity thing. And I know sometimes that's difficult for us, but you need to work these 4 problems and then check your answers to make sure that you have worked them correctly. I do want to also mention, before I put the page number and sign off with a picture, yes, it's going to be page 674 if you have your textbook with you. It's page 674. You're going to do 13, 16, 19, and 22. Doing this remote learning, you are not getting as much practice as what I would give you in class, because obviously these are more concise. But please be students of integrity and do these. Let me know if it's working for you or not. Check your work and email me, please, if you've got questions or concerns or things that maybe I need to change. But I do want to mention several of you have not handed in anything from the week before spring break. What that means is I need that today because I have to take attendance. And if I don't have anything from you, I have to count you as absent for those days. I can still take your work late, but if I don't have anything, I have to count you as absent. So you guys need to go back. I'd originally said, yeah, we'll hand it in after spring break. I've got to have pictures of everything that we did other than Friday's A-Math because I can see whether you've done that or not. And one day there wasn't an assignment. So I need pictures showing me that you have completed what needs to be completed, as well as today's assignment. So you'll need to make sure you email that to me. And I hope to see you at 1 o'clock. It didn't work.